Hello, everyone, and welcome to Versent's AI webinar series. My name is Jaden Kerr, a senior software engineer here at Versent, and I'll be your host for the next 5 weeks. Thanks for joining us as we explore the ever-evolving world of AI. In this series, we'll dive into what's possible today, what's coming next, and how to navigate AI responsibly. Each session, we look at real-world use cases, practical frameworks, and expert insights to help you move forward with confidence. Today's session will explore how Versent has reimagined the IT help desk. By combining Strands Agents with AWS Bedrock, we've automated repetitive Tier 1 support, empowered Tier 3 plus engineers with contextual insights, and introduced proactive ticket management that stops SLA breaches before they occur. Here's this week's speakers, Gareth Williams, Principal Solution Architect, and Sanya Kalande on their talk, Transform Your IT Operation from Reactive Support to Proactive Intelligence.
Okay, thanks for the intro, Jaden. If you've got any questions, please do put them in the comments section in the Teams chat. But with that, we'll get started. So transforming IT operations with AWS Strands Agents. As said before, I'm Gareth Williams, Principal Solution Architect at Versent.
And I'm Sanya Kolande, Technology Associate Consultant.
And a little bit of foundations to start off with. So what is an agent? So the standard definition seems to be a system that perceives its environment, makes decisions, and takes actions to achieve a goal. So in the example that we have over to the right, you have a research assistant. So given some sort of research-based task, you have an orchestrator agent that is able to delegate tasks to a researcher that searches the web and looks up knowledge bases. You have a writer agent, which is able to generate a report against a defined template. And then you have a critic agent that is able to assess the claims and the quality and demand any necessary changes, at which point the research orchestrator is then able to go back to any one of these agents and fix any proposed problems by the critic, rewrite the report, conduct further research, anything it deems necessary before giving the output. So I think it's a really good example of an agent that's going to perceive its environment, make some decisions, take some actions, and then ultimately achieve a goal. So some key patterns that we've employed when developing the IT help desk. We've used RAG, that's a common term for effectively taking unstructured documents and turning those into vector-based representations that you can search semantically. So it'll be able to return information that is pertinent to your query. We are also using multi-agent collaboration, similar to the example that you saw before, where we have an agent for looking up biographies and the skills of consultants, as well as looking up additional information about service level agreements and things of that nature. So we've got specific agents for those purposes. We have guardrails in place. So that is protecting us from unnecessarily or undesirable content being input or output from the agent. So that could be sexually explicit material. It could be somebody asking how you can try and hack passwords or similar. So there's guardrails in place to stop people, misusing the agent. There's also tools. So a lot of these sub-agents are attached to a number of tools. They would be attached in turn to APIs or similar databases, that sort of thing. And then we're employing the AI orchestrator pattern. So we have one agent that is orchestrating and delegating tasks to others below. But there are other patterns that are around, including like the judge, which is similar to the critic from before, and the router pattern, which simply hands off an exercise to another agent. We've also done some prompt engineering and context engineering. So that's a means of actually describing the task that the agent is expected to perform and making sure that it has all of the relevant content that it needs to execute on that particular task or goal. And finally, there's evaluation. So with agents, it's somewhat different to the modern day practices where we would have some unit tests, integration tests, and things that are similar. Because agents are non-deterministic, you can never really predict what response they're going to give you back. It's going to be similar in nature, but it's going to be worded differently each time. So we've been using an LLM to judge the response of our agent against some parameters and making sure it's behaving in a predictable manner. That includes what tools it happens to have used, the nature of the response, the completeness of the response. So there's any number of metrics that you can effectively unit test your agent against using the evaluations pattern. So the problem statement that we were given was skilled workers are doing tasks that AI could easily automate. And that's from Mal, the executive director of Versent Modern Run. So our solution that we proposed was to have specialized AI agents for all of the various tasks that underlie the operations of IT help desks. We would use tools intelligently, so integrations with the Jira API, RAG for data, and skills matching. And then we would use ticket triaging. So we would have an agent that was responsible for checking SLA details, making sure that the correct priority is placed on tickets, assigning the tasks to the relevant subject matter experts, and also attaching information to the ticket that was contextually relevant and useful for the person that was going to go and solve the problem. And also because Versent worked with a wide range of companies, the system had to have some degree of role-based access control. So we were using AWS Cognito, and that was able to make sure that any data, any tickets that a person was asking for from the agent had appropriate guardrails around it. So if you're from a particular company, you don't see any questions from another company or any data from another company. The metrics that we're using to measure the success of the project was, are we freeing up a full-time engineer to go and do more complex tasks? That was a key sort of outcome that we were aiming to achieve. And then speeding up the time to resolution. So by adding contextually useful information as to how you might solve your particular problem as stated in the ticket, pulling in that information, we were hoping that we would speed up the time that it takes to resolve that issue. Also, there's a reduction of tier 1 requests. So the simple requests like, how do I reset my password? We were hoping that we could use an agent to self-service and therefore greatly reduce the impact of that on the workload of the team. Similarly, there's the avoiding of contravening SLAs. So there are expectations as to the timeliness with which you respond and resolve tickets. So using information regarding those contracts and the impact of the issue, we're able to set an appropriate priority and then periodically go back into the backlog, make sure that the tickets that are reaching a certain time period are in line with the SLAs, and then changing the priority as necessary to make sure that we don't contravene that SLA. And finally, we were looking at perhaps resolving 25% of tickets automatically. So there are a number of tickets that come in like CPU utilization or memory utilization errors that are short-lived. They're short-term problems that naturally go away. Having the agent close those tickets as necessary, but at the same time have sufficient memory to know that actually this problem's occurred 3 or 4 times in the last hour. Perhaps somebody needs to go and have a look at this problem. So it's an intelligent means of actually resolving those tickets rather than just blanket responses, close all of the tickets that are of this particular nature. So a demo.
Let's see how our AI agent works in action. I'll start by logging in via the SSO, which will allow me to sign in as a Helix company user and ask an IT query stating I'm having trouble with an AWS VPC pairing issue. Behind the scenes, the knowledge agent is going to be using the search tool immediately to search Helix company specific files and knowledge base. It pulls out the troubleshooting tips tailored to this exact problem and responds in a structured manner. Now, let's say the issue can't be fully resolved right here. The agent asks if I would like to raise a support ticket. I'll go ahead and say yes. At this point, the ticket agent takes over, connecting directly to the Jira board through an API and creates a new IT support ticket. Next, the triage agent is going to step in and use the SLA tool to fetch company-specific response times and priorities from the DynamoDB, and then apply those rules to the ticket automatically. Finally, the BIOS agent is going to analyze personal profiles stored in the S3, and based on skill to issue matching, it assigns the ticket to the most relevant expert. Then it will give details of the ticket that it has recently created, and we can go access it on the Jira board. As you can see, after refreshing, the new ticket that has been created is visible with the knowledge base troubleshooting tips added to it, as well as the priority. And this is available for the person who has been assigned this ticket to view. It gives labels such as agent created and a company filter as well. We will see that the agent is also configured with guardrails, which will prevent any unnecessary or unintended actions by the user. So if you ask it, can you help me figure out how to reset my password by cracking into the Wi-Fi network or the network of the company, it's going to blatantly refuse because this is in violation of the security principles. And that is how our multi-agent system transforms IT support into a seamless, intelligent workflow.
All right, so now let's have a look at how the agent flow data ingestion works. Here we have a human interaction where the Versent user can go and add new IT support documents or personal bios into the SharePoint. Then an extractor lambda function is going to be putting it into an S3 bucket, after which we have the processor lambda, which is working with a Bedrock model to generate embeddings along with metadata like keywords and tags, which are going to be used at inference for semantic and keyword-based searching. From an agent interaction perspective, next slide, please. We have a user-based trigger where the customer or Versent support staff can access the agent via chat interaction on a web portal, as we saw in the demo, where the user query is going to be sent to an orchestrated agent, which is delegating it to an appropriate sub-agent. For instance, when we saw that the user asking for how to troubleshoot a certain task, the knowledge agent is invoked to carry out a RAG and fetch relevant details back to the user. An alternate interaction with the agent is via an event-based trigger, which includes a Jira webhook, which automates response. So when a ticket is created through other means by a person directly onto the Jira board, this webhook is going to be invoking the agent to add details like the knowledge base tips, the SLA details, and priority to the ticket which has been created manually. Our design philosophy is following an agent as tools perspective. So each specialized agent comes with purpose-built tools, which means that the specialized agents ensure that we have a predictable outcome from each sub-agent. We have 4 agents in total. First is the knowledge agent, which is using the knowledge-based searching tool to fetch troubleshooting tips from companies' scoped documents via filtering. Next is the Jira ticketing agent, which is managing the creation and updation of IT support tickets with real-time updates and custom field mapping. Then we have the triaging agent, which is using company-specific SLA rules from the DynamoDB to allocate ticket priority and response timelines. And finally, the BIOS agent, which is responsible for matching personal skill to issues, ensuring that the right expert is assigned every time. So one of the biggest benefits that we had was leveraging the AWS Strands SDK. So this made the building and running of our agents very easy from a dev perspective. The SDK gave us a developer-friendly agent orchestration with easy-to-interpret syntax, simple tool creation, and support for an agent as a tool design pattern. This meant that we could move fast without adding excess complexity. And it also provided us with seamless integration with AWS services. So we were able to directly plug into Bedrock models, which are AI models provided by Amazon, apply Bedrock guardrails for safety, and use knowledge bases for grounding responses using vector storage and retrieval via S3 vectors. Now I'll hand it over to Gareth to show us how the services came together in production.
So a look at the application deployment view. This might look reasonably familiar to anyone that's deployed a containerized application in the past. So we're using application load balancers going into ECS, so Elastic Container Service. The use of the ALB was particularly useful because it allows us to stream responses back to the user. So rather than having to wait for the agent to finish its entire response, it can instead piece by piece respond to the user. It's common with a lot of the AI agents that you're seeing today. They'll send you snippets back of the content. The agent itself is a bundle of all of the agent, the sub-agents, and all of the tools that are associated with it. So they're all inside of the same container. And then they are reaching out from that container to Bedrock, for example, for the various models. So we're using Anthropic models in this case. And it's able to use those for inference. Similarly, it reaches out for any data needs, so such as the SLA data. So that's to DynamoDB. Also Bedrock guardrails, so that's in place for incoming requests, making sure that the request wasn't inappropriate, as well as making sure the output wasn't appropriate. So it's called twice through a life cycle. And then you've got the various knowledge bases. So this is for the semantic search and finding relevant documentation or relevant bios for the given request. Then when it comes to the ingestion pipeline, we have scheduled events from EventBridge, which are triggering some extractor lambdas. They're going off to SharePoint, extracting the bios and the support documents and bringing those back to S3. We then have a lambda that is triggered from that create update event, which is using a Bedrock model to embed the various chunks of data and turn those into vectors that are then stored into S3 vectors. That was a huge cost benefit. So prior to that, we've been using OpenSearch, which was considerably more expensive than S3 vectors in the bucket form. And then as well, if there was any need for data such as DynamoDB and the SLA data, the processor then exports the data into there as well that the agent can then go on to use. When it comes to observability and in understanding how your agent has been behaving, we had to set up some additional architecture. So we have RDS database, which has all of the traces within it. We have Arise Phoenix, which is the key component really here. That has all of the agent related traces. And it's giving you a rundown of each invocation of the agent and tells you roughly how the agent has thought and responded to a given request. So to delve into that a little bit deeper, you can see here on the right hand side, there's an example of a trace. So you can see the output that the agent has given. You can also see the number of tools as an array that the agent has used. And if there was any thinking that the agent has done, then that would appear inside of there as well. So you could understand perhaps the reasoning of the agent and why it elected to use particular entities. You'll see in the top left-hand corner, there's total cost. So that gives you an idea of the expense with the various Bedrock models that this invocation has cost. And similarly, the latency, so how long it took for the response to be completed and returned to the user. So that allows you to constantly evolve and iterate so that you can optimize for cost and latency as needed. Other capabilities of Arise Phoenix that were particularly useful. It has the ability to run evaluations, both deployment time. You can run it somewhat in real time and also a given schedule. And that allows you to evaluate the agent's responses for relevance, completeness, accuracy. You can also have a look for hallucinations. So I'll look through that trace and see if there's any claims that the agent is making in its output that are not actually existing in the context that the agent has been given. And similarly, toxicity. So if the agent is behaving in an unsatisfactory manner, you can get a flag from that. And another really useful capability of Arise Phoenix was that you can create data sets. So rather than having to dream up all the various means by which somebody might invoke the agent, instead, you can use real world data, turn that into a data set that you can then run against the agent over time. So you're constantly improving the quality of the evaluations that you're using to make sure your agent is behaving. So there's all sorts of key learnings that we could go into, things like how we overcome the agent coming back with some odd responses, and that was more about right sizing your agent and making sure that you have the right model in place. But the key outcomes really were run evaluations often, everywhere, so that you're constantly evaluating the agent. So using them as unit tests effectively. So between deployments and prompt changes, you're not, breaking the behaviors of the agent. Similarly, guardrails are your friend. So making sure that the agent can't be misused in any way, shape, or form. But also, we found that if you didn't put topic-based guardrails in place, you're effectively launching a model. So it would be a cheap way for somebody to use the Anthropic models if we hadn't put topic-specific guardrails so that the agent only responds to questions of an IT help desk's nature. And then closing that software development lifecycle loop. So that's really important here. It's not like the days of launching just a website where once it's launched, it's broadly complete. You need to really observe and iterate on the prompt, on the context, on the tools that the agent is using and the composition of those agents, so that you can make sure that the accuracy, completeness, the cost, and the latency of the agent is optimal for the end users. So that's an overview of the IT help desk. If anybody's looking for, they have their own agent that they're looking to build, we have the Versent agentic experience, and we'd love to help you with any of those endeavors. So this is a 4-day long process, of which we would expect probably a 1.5 day upfront time commitment from yourselves. That would allow us to do an intensive discovery phase where we identify and prioritize the opportunities that your problem statement and your business have, learn about the new emerging use cases for AI, and co-design the solution, building a plan of how you might actually deliver on that agent and that want that your business might have. We might even be able to work towards a proof of concept at the end of that 4-day period as well. So if anybody's interested, we'd love to hear from you. Thank you.
Thank you, Gareth and Sonia, and thank you for joining us for today's session. If you're interested in the workshop, you can scan the QR code on the screen or reach out to us at ai@versent.com.au. If you have any questions or follow-ups on today's topics, you can reach out to Gareth or Sonia at the emails on the screen. So what's next in the series? We still have 4 weeks to go. Next week, week 7, the 25th of September, our speaker is Steve Jones, Principal Solution Architect, and Vinitha Kalia Perumal, Lead Engineer, on their talk, Reimagining Voice AI, Human Conversations Without the Smartphone. In other upcoming sessions, we'll dive into topics like AI-powered customer experience, Gen AI use cases in healthcare and operations, and how to build secure, scalable AI systems. So keep an eye on your inbox for the next invites. Thanks again for being part of the Send AI webinar series. We look forward to helping you unlock the full potential of AI safely, ethically, and with impact. Have a great day, and we will see you next time.